So now by adding a new condition, we're going to define a function. So let us move on to the definition of a function. I'm writing them side by side so you see the difference between them. A function like f from set A that we call the domain to a second set that we call a codomain to set B. Guys, set B is not called the range yet. This is codomain. Satisfies the following conditions. First of all, for every x value in set A, for any x belongs to set A, there is a y value in the codomain in your second set. Okay, so far so good. What's the meaning of that? It means that you can definitely find ordered pair belong to this function. So far, your function is just a relation, collection of ordered pairs. Second condition, adding the second condition makes this relation f to become a function. For all x values in A and y values in the codomain B and Z in your codomain, so I'm taking two y values. Take a look at this. I'm taking two y values. If x and y is in that relation, x and z is also in that relation, it means that if you have two y values associated to the same x value, then y and z must be equal to each other. Otherwise, this f is not a function. It's just a relation. So let us write it down here. If the second condition is not met, then this is just a relation. A bunch of points, like this case here. It's not going to be a function. Like x squared plus y squared equals to 1. That is a relation. Relation R, which is the set of x and y's, such that x squared plus y squared is 1. This guy doesn't pass vertical line test. Let's move this a little bit here so we can write down the note here. Doesn't pass the vertical line test. So vertical line test, it doesn't pass vertical line test. Remember that if you have just a circle here, a random vertical line has more than one intersection with the graph. So it doesn't pass vertical line test. But for your function, again, to each x, you're allowed to associate just one y value. Otherwise, it doesn't pass vertical line test. So what are the examples of functions? You saw a lot of functions back in algebra, pre-calculus, calculus. So for example, function f, which defines as 0 and 0. 1 and 1, 2 and 4. This is a function with 3 points. So your function might be just a very well-behaved set of points with 3 points. That's it. Of course, it's a function. Why not? Believe 0 and 0, 1 and 1, 2 and 4. This function has only 3 points. This simple function has 3 points. Of course, we're not worried about this. Later on, we can make it more complicated. We can define function g to be the set of all x and y's such that y is equal to x squared. You learned about this before. It's just a parabola. So if you want to graph this function, you have a bunch of points, you graph them, you connect them together, and you have your parabola. So the difference between different functions. You have a very simple function with 3 points, and you have more complicated function with a lot of points. This function, this is a quadratic function. Of course, you can define as many functions as you want. Just note that all of these functions, they pass vertical line test, but for a relation that is not a function, it doesn't pass vertical line test.